So Marc Bonnet is a technologist field application engineer at Western Digital EMEA. He's working and collaborating with strategic customers who architect, develop, and build new storage solutions for their data centers or enterprise platforms. He's been working in the disk drive and storage industry for more than 25 years. And he owns a master's degree in physics and engineering degree in microelectronics.
Okay, good morning, everyone. I'm happy to be here with you for my first LAD. Thank you to Gael and CEA for the invitation. So today I'm going to talk about how to improve a parallel file system like Lustre using the NVMe oF Fabric solution, storage solution. So I want to point out the fact that I'm not, the credit for this presentation and for the POC belongs to Jonathan Flynn, who is part of our field application engineering for platforms based in Colorado Springs. So I'm sure you are all familiar with this traditional parallel file system architecture with the management server, the management target, the metadata servers, the MDT, and so on. So basically, the one issue you are well aware is in case of one OSS failure with this active-active failover architecture, basically you have one server taking care of the workload for both OSTs. Okay, so this induce reduce OST performance, or you need to scale your server performance to take care of this situation. So basically, the solution is not cost optimized because it needs to be the computer resources and the network resources need to be sized to face this type of situation. Okay, now let's look at the storage enclosure evolution and the challenges, okay? So this is a traditional JBOD product using a SAS dual-port drive. If you want to improve the performance of your parallel file system, then you can move to same type of enclosure with SAS SSDs. But basically same architecture, same topology. Now we have this new, or let's say, this very high-performing NVMe devices coming with a dual port as well. But this is really a completely different device. It is connected to the very high-performing bus, the PCIe bus, Gen 3, Gen 4, soon Gen 5. So how can we handle and get the most performance out of this type of device in a parallel file system? The current approaches are basically could be to use a single OSS with a RAID layer, and then you have basically RAID protection with either software RAID or hardware RAID, but in this there is very limited, benefit with this solution. Basically, you have no protection against the server failure. Okay. Also, we have experienced that with traditional software hardware RAID architecture, you can get limited performance. Now you have also the possibility to use a 2U with a 2U server with dual node with 24 NVMe device. You can create this time 2 RAID groups, RAID 5. So this is a much better solution from a failure standpoint. But again, with that solution, you have a limited number of SSD to address. Basically, with 2 servers, you have only 12 SSDs. And you have also quite an issue with the number of devices to have a pertinent RAID level. Meaning, if you want to have a traditional 8+1 or 8+2 base 2 OST RAID layout, basically you are going to end up with using only 20 devices out of the 24. So not really an optimized solution. Okay, this is the 2U HA server that we used to sell from Western Digital, but we moved to a new solution now. So this new solution is basically a 2U24 NVMe JBUF, okay, enabling a standard NVMe PCI SSDs that can be shared through an external enclosure through the network. Okay, the enclosure is a 2U with also 24 devices, very similar to the SAS enclosure we saw earlier. But this is simply a JBUF. There is nothing to manage the RAID and so on. In terms of networking, this solution, which is on our portfolio since 2 years now, is coming either with it's coming with 2 I/O modules to get the high availability support, and you can get either 1 Ethernet port, 100 gigabit per IOM, or 3 ports for a total of either 2 or 6 Ethernet ports. So maximum bandwidth of this enclosure is 600 gigabit per enclosure. Currently, with the platform we are selling, it's only Rocky V2, but happy to tell you that soon we will release the TCP. We will support TCP, which is, let's say, somewhat easier and natural transition for our customer. And of course, we have a BMC for management, and the enclosure is coming with our own API to manage the enclosure components and to manage the storage. By the way, the product is called OpenFlex. This is a new brand name at Western Digital because effectively NVMe over Fabric provides a lot of flexibility compared to previous architecture. So, and this is also an open architecture. So now, as I said earlier, we observed with NVMe devices some limitation with RAID layout. So typically, parity calculation are done on the kernel space, which is not very efficient. So to make the solution really efficient, we need some basically hardware-based parity calculation. And we have looked at different options. Okay, one option is to use CPU extension from the x86, AVX, AVX2, which are available. There is other solution to use a GPU. There is on the market a solution named GRAD, which offers this type of possibility. And similarly, you have a solution, we imagine a solution with a FPGA, okay, for parity calculation. And this solution, are clearly, a key element boost the performance and get the most of the performance from your NVMe devices. These are the solution, and now this is a concrete example we have tested internally at Western Digital with a solution named Radix. Okay, so this is a software solution. Radix is used to be a Russian-based company. I think that they have moved to Switzerland now, but the solution is still available. These are the detail of the configuration we have tested. So we took 8 NVMe drive. In that example, we only use 2 PCIe lanes. Okay, this is and they were Gen 3. So we compare the raw performance with MDM, with the 8 drive, RAID 5, and then with Radix. And we did 2 benchmarks. One was a sequential write with 128K, and then the random read and write with 4K byte blocks. Okay, you can see for reads, no real benefit out of this Radix solution, but for write it's obvious, and we have observed on random IOs for write. Basically, the performance is by 10 improved, and by 6 for sequential write. Here, just something important. Of course, this performance is quite dependent from the stripe size. Okay, I mean, if your block size is 128K and you use stripe of 16K with 8 drive, physical 8 drive, then you end up with only 7 drive to write, and you have a read modified write, and the performance is impacting. So the 7 plus 1 solution for that type of example is not optimum. So you better to use 9 drive. So you need to watch this type of setup. So let's look at the traditional HA server performance and what you can get out of the 2U24 HA server. Basically, you have 24 devices, and you have 2 nodes, so OSS1 and OSS2. You can create using 2 namespaces per device. You can create 6 OST. Okay, by the way, our devices and NVMe devices all support multiple namespaces, and you can create up to 128 namespaces, but commonly less namespaces are used. So in this example, you have basically 2 OSS, 6 OST, 3 OST per OSS, and you have each OSS is, of course, active and passive. Active, so OSS1 is active on OST 1, 2, and 3, and passive on OST 4, 5, and 6. Okay, we found difficult to design with this type of architecture the solution to in failover condition, because basically. If OSS1 is going down, you only have OSS2, which can take care of the OST of the OSS1. Also, in such a condition, this is difficult to get the full performance of the solution unless you have basically provision your performance on CPU, on network for the server to take care of this situation. So basically, you need to design and to size your resources to take care of the failover situation, to plan for a failure of one node. Also, performance needs to be to have 2 times 100 gigabit to support the performance in read. Okay. And as mentioned earlier, without any solution, hardware accelerated RAID parity calculation, you end up with a very poor performance with MDM. Okay, so yeah, the challenge are basically limited flexibility, very limited flexibility in case of failover situation, and as said before, the way to create OST is might not be optimum to get the maximum performance, and you may end up with unused device, like I said before. In this example, we with these two nodes with the optimum RAID layout, you have only 4 OSTs, and you end up with 4 spare devices. Okay, from a rack diagram standpoint, with this type of solution, in this example with 10 dual node OSS enclosure, okay, we have 2 OSS per enclosure, 6 OST. So at the rack level with 10, you have 60 OST, and the big point is basically you end up with power consumption which is very significant of 17 kilowatts. Okay, so you need to basically to be ready to cope with this type of power. Okay. And the key point also is you spend 50% of your resources you need to basically reserve and plan 50% of your resources to plan for a failover scenarios. Now comes the NVMe over Fabric architecture. Okay, so the principle of this architecture is this is any to any topology, meaning on this architecture we have worked on. We are proposing to use, for example, one device from multiple enclosure. So we can stripe the RAID layout with one device per enclosure, and you have then a very flexible layout like 4+1 or 8+1 or 8+2 and so on. So very flexible. The other key point is each OSS can can address any OST. A very flexible solution because everything is assignable, role assignable through the fabric. Okay, you don't need to plan for 50% additional compute and network resources because of this architecture. So. In this example, you can see you have an idle OSS 3, which is ready to become active as soon as one node will go down. In fact, this extra OSS in idle mode is not necessarily required. Okay, you can plan additional resources on your OSS. Let's say add. For instance, 10% additional compute and network resources to each OSS, and you don't need to have an extra OSS. Okay, and of course, with this solution, we will use the hardware accelerated RAID solution to take the full benefit of the NVMe performance. So the benefit of this solution is, of course, the resiliences. Any SSD, any server, any enclosure, any network link can fail. Okay, the flexibility with the RAID. Okay, we are not like with the 2U24 dual node server, limited in terms of flexibility with the RAID, losing. I mean, having up to 4 devices unused or So this is very efficient in terms of cost. Yes, instead of having 50% of additional OST server, you only have a limited cost needed to plan for this with this architecture. And you have, and this is quite important, you have a full flexibility to select your OSS server. This could be a 1U server without any NVMe. So a great level of flexibility to choose your server and assign the role you want to each of these server. In the POC we did, we selected all the same server to assign different role. And the performance, of course, the performance is on right is improved, of course, with accelerated hardware accelerated solution, but also because we have the free flexibility to do basically a RAID layout which will max the performance. So just to finish, because I understand that I will only cover 50% of my presentation, but you will get the detail on the backup slide. If we look at the performance here, you can see with a raw solution, raw performance with 8 drive, the OST is 7.55 gigabyte per second. You have 2 OST per OSS, and at the OSS level, you have twice, so about 15 gigabyte. With the MDM, basically, you only, without any acceleration, you only end up with 11% for write bandwidth. With the accelerated RAID, you would jump to 65%. Then, if you do a better layout in terms of RAID, you jump to 93%. Okay, and again, with having very limited resource provision for to face a failover situation. So we believe this is a great solution to prepare the new generation of parallel file system. Thank you very much.
Thank you. We have just time for one question. Nobody? I think they're hungry.
Okay, anyway, don't hesitate to send me an email. My email address is very simple, marc.bonnet, B-O-N-N-E-T, @wdc.com. I'll be very happy to answer or to get help from my colleagues to answer any question you may have. Thank you.
Thank you.